Good morning. It's 9:20 already. Um, this is really bad. People still coming in late. Uh, but today we have a lot of things to cover because this is the last class, right? And in this Monday you need to do your final presentation. So today we are going to talk about assumption and simulation. This is actually quite complicated topic, and I also need to reserve some time to talk about the final, right? So we cannot wait any longer. Let's just get started, okay? Actually, this is very bad that you come late, because although we have this video recording, but if you do not come in time, then you lost the context, right? Because in the beginning we need to talk about, bring everybody into the context that we are going to discuss. Is this microphone okay? No, huh? But this is not a chargeable thing. Let's see. Better? Okay. So so let's get started. Okay, let's get started. So let's take a look at this chart that we have used many times already, right? Okay. So in the second half of the semester, we basically is no longer doing the holistic and group-based exploration and analysis. We are talking about the individual prediction, right? We make a model, right? And that model actually predict every individual customer's behavior, right? As we can see that. Now let's take a look at today's material first, okay? So today, if you go to the unit page, you will see that in the in today's folder, we only have a PowerPoint file, okay? That is because the code and data has already been given last week, okay? If you go to your code folder in your computer, in your code folder, there should be a folder called Tafang 567, right? Okay? So the code and the data we are using is actually already in the Tafang 567. So today we do not have a code, and right? Okay. The major notebook that we are going to cover today is under this Tafang 567, and it's 7 simulation. Okay. Okay. I will say it again. Today the materials only have the material folder. We only have a PowerPoint file, and the code and data has already been given under your code folder and under the Tafang 567 folder. And basically, we are going just have one notebook to cover, right? It's called simulation. Okay. Although there's only one notebook, I also have two app it's kind of like a simulation app to help you do your final. Okay, so today we have one notebook and also 2 simulator, and it's already in the Tafang 567. Okay. Now let's get back to here. So if we go into this 7 simulation RMD, and then let's execute the first Gochang. Sorry, I should set it as working directory first, okay? And then this is the first code. If you have all of the packages installed, is load a data frame called B, capital B. Anyone get here? Okay. So under this B data frame, there are 2A531 observation. What is the observation? Each observation refer to what? We have 2A531. What is this data? Every data starts with the customer ID, right? So this is 2A531 customer. So when we do the prediction, we actually predict every customer's purchase probability. We predict their expected revenue, okay? That is what we do last week. Still remember that? Okay, so we already have a model, we already do the prediction for every one of our customer, 2A531 customer. We know their buying probability, and we also know their revenue, right? Expected revenue, okay? That is prediction. But the prediction is not what we want to do, right? What we really want to do is we want to design and choose the marketing instrument, right? We want to, for each of this marketing instrument, we want to choose who to apply, right? And when we apply that marketing instrument to a certain group of target customer, we want to know its cost effectiveness, right? And in order to do that, the prediction is not enough, right? We need to do some assumption, and then based on that assumption, we can do some simulation. That is what we are going to cover today, okay? If you still remember the diabetic case, right? We actually predict the probability for each patient's poor care probability, right? But after we know the probability, we still cannot do our decision, right? If you still remember that, in order to do the decision, we need to assume the payoff metric, right? So the prediction give us the probability for each of our customer or our patients, right? But in order to know the expected payoff, we actually need to do some assumption about the cost effectiveness of the drugs, right? Isn't it? Right. The same thing when we are doing the marketing, right? Now we need to do some assumption about the cost effectiveness, about the it looks like I lost one over here. We need to do some assumption about the cost effectiveness of marketing instrument, right? Okay, so the basic idea is like this slides. Okay, basically these few slides are we already go through before, right? So the new slide here is here. Okay, actually I went through these slides in last week's class a little bit, right? Still remember that? Okay, the reason that we want to do the business analytics, marketing analytics, is because that we want to design and choose market instrument, right? And we want to choose the target audience, right? And then we want to calculate the cost effectiveness. And besides the prediction, we need to do an assumption of this market instrument cost effective. Okay, so the reason that we want to do that we want to do campaign, want to apply market instrument is because that every instrument actually incur a cost, right? Why do we want to spend that cost? Basically, we want to increase customers' buying probability or increase their revenue contribution, is it, right? To be concrete, for example, if we want to send out a cash coupon, right? The cash coupon is supposed to bring up the buying probability, right? So we already have a prediction about every customer's buying probability, right? But if we give them a coupon, right, a cash coupon, then their buying probability would increase, right? That's why we want to set out a coupon, right? Because the coupon incur cost, and with that cost, we want to have the effect, right? And the cost effect, if we add the delta pi into pi, then we'll have pi prime, okay? So this instrument is going to have the effect that raise the original predicted pi and mi into pi and mi prime, okay? So with this cost, we are supposed to like raise pi or mi, okay? Now, because we do not have too much time left, so today I just assume that this market instrument will increase pi, right? Okay. So when pi increased, okay, the expected revenue of this customer, for every customer, the underscript I represent every individual customer, right? So for each of this, after we apply this instrument, we know that, first of all, we know delta P, right? And then if we know delta P, we'll know how to calculate P prime, and then we can calculate the revenue increment, right? And the revenue increment has to multiply by the margin, right? Because revenue is not profit, right? If you want to translate revenue into profit, you need to multiply the raw margin, right? And now we know the profit increment, but the profit increment need to deduct by the cost to get the net profit, right? Okay, so this pi I is the net payoff after deducting cost, right? It's the net payoff that we apply this instrument to customer I, right? So this calculation is actually calculated at every customer's level, right? Okay, we apply that instrument and we raise each customer's buying probability, and then we can calculate the revenue increment, the profit increment, and after deducting the cost, we know the net effect of this instrument to customer I, right? So if we apply that to a group of customer, we basically just sum up their expected payoff increment, right? So this is capital pi is actually the net profit, okay, the net payoff when we apply this instrument to a certain group of people, right? This logic, is it clear? Any question about this logic? Okay. So that's what we are going to do, right? First of all, we want to assume that if we give a cash coupon of cost C, then the buying probability for every customer would increase by delta P. Okay? Okay. But here comes a question, okay? The cash coupon has a face value, right? Okay? And the more value that I give, the higher the delta P would be, isn't it? Right? If I give like $5 coupon, right? Maybe nobody would increase their buying probability. Okay. If I give a like $20 coupon, well, some people may not care about $20, right? Some people will, right? Okay, and the probability of buying is increased by a small amount, right? But if I increase the coupon money to 50, to 100, to 200, right? We can expect that the delta P would increase by C, right? By the strength of, we call it the strength of marketing, right? And the stronger the instrument is, it will become more costly, right? And it will also become more effective. You bring in a larger effect, right? So we want to make the assumption that the effect of an instrument is increased by C, okay? And with that, we introduce this kind of S-curve, isn't it? Right? We already explained what is the S-curve, okay? So basically, most of the market instrument has an S-shaped cost-effective function, okay? As I has explained it, if you send the cash coupon like just $5, maybe this is cost, right? The cost of the instrument, okay? Take the cash coupon as example. If I just send $5, maybe the P price is the delta P, the same thing, right? And this X is the same as C. So if I just send like $5, it barely has any effect, right? If I increase to $10, it will have some effect on buying probability. It's like, okay, if I keep increasing this X, then you will see that the buying probability will rise up. Okay, this is kind of optimistic, right? I just send a $15 and the buying probability increased by 10%. It's kind of like optimistic, right? But it's just the just to illustrate this idea, right? But when you keep increasing your X, right, the probability increment would the probability would increase by the cost of the value coupon, but up to a point, right? We learn from economics 101, right? There is a kind of thing called diminishing marginal effect, right? Still remember that term? Okay, diminishing marginal effect. So when that cash coupon rises to a certain point of time, then somebody just don't use a coupon no matter what, right? So when the money come to a certain level, it would flatten out, right? So that is what the S-curve is, okay? Right. So we want to make an assumption that the cost effect of any instrument, basically all of the instruments will follow this pattern, right? You can do advertisement, you can like spend time to do an event, right? You can do some send some gift, right? You can like do a discount, do a promotion, right? Okay, but no matter which instrument you are using, the more cost you spend on that promotion, the more effect it will like. But the relationship is not linear, right? It's kind of like S-shaped type of function. Okay, so in R we actually has a function called logist, and in this mathematical form, we actually can control the S curves three key characteristics, right? The S curve actually has three key characteristics. The height of the S curve, right? Some S curve is higher, right? Okay, some S curve is lower, right? And the height is actually the maximum effect of that instrument. Okay, okay. So M is the first thing that we can adjust. And the second thing that we can adjust is B. B is actually the middle point of this rising slope. Okay, so the higher the B, the costlier, right? It will cost more money to take effect, right? So if I increase B, the S curve will shift to the right, right? It means that you need to spend more money to take the same effect. Okay, so B is the second important characteristic of S curve, isn't it? Right? It controls the position, horizontal position of the S curve. And the third characteristic is less important. It's the A, which is just the width of the rising slope. Okay. Sometimes it is very wide, right? The S curve is very wide. Sometimes S curve is very narrow. When you have a wide S curve, it means that this instrument is sensitive, right, to a large range of cost, right? So when you have a narrow rising slope, it means that this instrument is only sensitive in a very short range of cost, right? So if we write a program to simulate the cost effectiveness of marking instrument in this form, then by adjusting M, B, and A, we can actually simulate any instrument, right? Right? Because we know that for every marking instrument, the cost effectiveness relationship is like an S curve. Okay? Now, as long as we can control and manipulate M, B, and A, by manipulating these three parameters, we basically can simulate any different kind of marketing instrument. Okay? So whatever instrument you are using, like cash coupon, advertisement, promotion, a gift, whatever, the more cost you spend, the larger the effect is. Okay? The difference is their MBA, right? Some instrument will have a higher maximum effect. Some instrument will have a lower, right? That is the M parameter. And some instrument are more costly, right? You will have a larger B, right? The S curve will shift to the right. Okay? You need to spend more money before you take effect, right? Okay? And the A is the width of the sensibility for this instrument in a range of cost, right? And we specify these three things. We can specify the effect of instrument, right? And this is the assumption that we want to make, right? And if we do the assumption in this way, we can adjust our assumption very easily, right? As I will show you in here. Let me turn on this simulator first. Okay, if you run this simulator called TF7AEN simulate, that push this run button, and then actually I can open it in the browser. Okay. Give it a second. Okay, so here we have, as you can see that here I'm simulating two different instruments, the pink one and also the blue one. Okay, so this pink instrument, I can adjust the M. If I adjust the M, you will see that its height will increase. For example, say this way. As you can see that the M control the S curves high, right? And the B control the cost, okay? This is cost, this is effect, right? So if I increase V, the cost would, the S curve will shift to the right, isn't it? Increases to 50, increase to the right, right? Okay, and then I can adjust the width, right? Here is its effectiveness is like 50. If I shorten, you see a very steep rising curve, isn't it? Right? A steep rising curve means that this instrument only take effect from about $40 to $60. Okay, and after that, its effect will saturate very quickly, isn't it? Right? It means that the effect rise very fast against the cost, but the effect will saturate very fast. Okay, so by adjusting this MBA, we basically can simulate whatever instrument we are doing. Right? Okay, so this is the way that we will do assumption. Okay, and after we do the assumption, we can actually simulate when we apply that instrument to a group of selected people, then what is the cost effectiveness? Okay, we can see a few things. First of all, we can see that because we want to maximum our expected return, right? So for this ping, if we do have instrument and the S curve is like this pin one, we actually can do some calculation based on this logic, right? And then we can see that it's easier, right? So basically, you can see that if I want to use this instrument of this MBA charactered by this MBA this set of MBA value, then I better set the cash coupons face value to about like $65. Okay. $60 also, right? And with that, I can apply to less than 20 million customer, right? Okay, and as the result, I will increase my expected return value after deducting the cost. It means that I would earn about $750K, right? Okay. So that is the thing that we are going to do today. Okay, I will like guide you through how we do the assumption, and from the assumption, how we can find out the best cost to use, right? Best strengths of marketing, and then we can select our target customer, right? And then we can calculate the net expected return if we apply this instrument of such a cost to a selected group of people. What is the net expected return? And that is exactly what you are going to do in your final, right? Isn't it? Okay? Okay, let's go back to our slide. Okay? So the basic, sorry, there's a mosquito here, like, very troublesome. Okay, the thing that we are going to do is pretty much like this, right? Okay, so here we do this is we already done, right? We already do a model and do a prediction already, right? So what we are going to do today is basically in this front, right? We have different instruments, and the different instruments are characterized by the set of parameter MBA, right? Okay, and that's basically assumption, just the assumption that you want to set it, right? Okay, and after you do that assumption for the cost effectiveness, right? Then we can do a simulation. Then we can calculate the expected return for each of this instrument, right? So you can allocate budget and then maybe do some optimization. Okay, so that is basically what we are going to do today, and that is what you are going to present in your final presentation. Get it? Any problem up to this point of time? So far so good, right? That is what we are going to do today, and exactly this is what you are going to do in your final, right? Okay, so today in this notebook I will go through the logic from do assumption on the S curve, and then how to like calculate how to find out the best cost, right? The cost need to be optimized, isn't it, right? And then after you optimize the cost, you can select a group of customer that you can apply this tool, right? And after select that group of customer, you basically can estimate the expected return, right? In this notebook, I will guide you through this process. Okay? Good? Okay, so let's go to the slide. Because everybody coming late, so it's already 9:53 already. But however, we need to catch some time, otherwise we do not have time to. After we finish this notebook and simulator, I actually want to spend some time to like talk about the final, how we calculate how we do the cross rating, right? And what you are going to do in the final, right? Okay, so let's catch up and do some thing in this notebook first. So I need to stop the simulation, right? In order to run the notebook. So you need to stop the simulation. If you have a right light here, let's turn the right light, and it would kind of like this concept. Let's change to concept. And as I say, if you run this Cochang, you should see a data frame B, and in this data frame B, I have every customer's expected buying probability and expected revenue, right? Okay, So that is data frame B. And sorry, I think I have run the wrong thing. I should close. I should jump to the 7 simulation RMD first, right? Okay, and then again I can. But actually, it's basically the same thing. So I can like do this. So again, we have the and then before we do anything, we can actually take a look at the buying probability and expected revenue, right? I want to see. So you can see that this is the distribution of buying probability, and this is the distribution of the revenue, expected revenue, right? And that is prediction. We already done. Okay. So based on that, we can also do some, right? Some chart. I think we have, yeah. This is just to show you that I think we can do it here better. This is just to show you that for every age group, right, we can show their average buying probability, their average expected revenue, and also their the size is the number of customers, right? Okay. So this is very important, right? Because for age group, every age group have their different characteristic. Okay, that is we already done in prediction, right? But now if we want to, I told you that today we are going to do this part, right? And in order to do simulation, you need to do assumption first, right? You want to make assumption about the cost effectiveness of marketing instrument. And as I say that we will assume that the cost effective relationship for any instrument are a S-shaped curve, right? And we can actually adjust the height, the position, and the width of that S-curve by 3 parameters called MBA. If we use this mathematical, expression, okay. Well, this expression might look quite complicated, but in C function, in the R, programming, we can very easily like define this function, right? In R, we can define the function, and this function actually has 4 parameters, okay? This is MBA, right? And this expression is basically just this expression in R programming language, okay? So you don't have to worry about that mathematical thing because I already write for you, right? Okay. So with that, and so you kind of like delta P of X, right? This mathematical equation should be read by function delta P of X given MBA, right? Okay, let me say it again. So this is the function of delta P of X. So this is a function of X, okay? Which means that delta P will change by X, okay? Given MBA, right? And the MBA will determine actually the function definition was just 1 line of code, right? The rest of code is just to plot, to do this plot, okay? So as you can see that if we set MBA to like 20, 30, and 40, M is the height, right? So this is 20%, right? And B is the middle point of the rising curve, right? We set it at 30, okay? Isn't it? Okay. And A is the width. The width is 40, right? So the rising slope starting from 10 to and ended by 15. Okay. If you change MBA, you will have a different curve. Okay, and the cost effectiveness of the instrument will change when you do this adjustment. Okay. So that is the way we do a assumption. If we do assumption this way, we call that this assumption is flexible, reasonable, and general, right? It is the general assumption because it applies to all of the market instrument, right? It is a flexible assumption because we actually can adjust the height, the position, and the width of MBA to whatever we want, right? So it's very flexible. And it is reasonable because we know that for every instrument, their cost effectiveness would follow this S-shaped pattern. Okay? So with that, in one line of code, we make a general, flexible, and reasonable assumption that can simulate the cost effectiveness of any market instrument. Just one line of code, right? So this is the powerfulness of programming, and this is the elegance of R programming language. Okay? Let's take a break. We'll be back at 10 after 10.
Professor.
Hey.
Question, like, because we got our prizes for the midterm, right?
You, you get the prize? What? You can say it again.
We get our monetary awards for the midterm exam, right? Like 2,000 for the first place, 2,000 and a half, 1,000 and a half for the second place, and stuff like this. Didn't you mention that we were getting?
Yeah. I'm actually will get some budget for the prize. Yeah.
And does the score combine with the final exam, or they are two separate? There are two separate prizes.
It's just for the final. Two separate prizes.
And what about the midterm?
Actually, the midterm I don't have the budget to do the prize, so I just set all of the prize to the final. Okay.
So our midterm score is irrelevant for the final.
Yes, they are independent.
So we don't get any prize for the midterm.
Well, actually, we have a total budget of like 10,000, and well, I just decided to allocate all of the prize to the final.
Finals.
Yeah, the final. Yeah.
Okay. Yeah. Thank you.
Just okay. I wish that I can have the budget for the thing, but
no
actually,
worries.
yeah. Yes.
就是我们想把就是我们要去做分析的话，我们把就是分群的方式。
哎呦，等一下，我忘了，
啊，
忘了把这个。